Welcome back. In our final explainer of this series, we are making a really crucial leap. We're going from managing just one container to orchestrating a whole application. We've basically mastered the solo musician. Now it's time to conduct the entire orchestra.
So here's what we're going to cover. First, we'll talk about why things get messy when you add more containers. Then we'll introduce our hero, docker-compose. After that, we'll break down its configuration file piece by piece, see the workflow in action, and finally, we'll do a quick recap of our entire journey, right from the very beginning.
All right, let's set the stage. We've figured out how to solve the problem for a single container, and that's a huge win, for sure. But what happens when our application, as they always do, starts to grow?
Right. We started this whole journey to solve this classic, frustrating developer headache. Docker files and containers. They make sure our single application is neatly packaged up with everything it needs. It becomes this portable unit that runs reliably anywhere. So for one service, the My Machine problem, it's solved. But here's the thing. Modern applications are rarely just one single thing. They're usually made up of multiple little services. You might have a web application that needs to talk to a separate database, for example. Each of these services lives in its own container, and, well, they need to be able to talk to each other. And this is where things get messy fast. Look at this. On the left, one service. It's just one clean command, docker run. It's pretty simple. But look at the right. Just to get two services to talk to each other, we suddenly have to manually create a network, start each container with long, complex commands, and link them together. This isn't scalable. It's just a recipe for typos and headaches. It's managed chaos at best. So the big question is, how do we bring some order to this multi-container chaos? How do we get back to that simple, repeatable process for our entire application, not just one little piece of it?
Well, the answer lies in a tool that was designed specifically for this problem. It's time for us to meet our orchestra conductor, docker-compose. I want you to think of docker-compose as the conductor of an orchestra. Your individual containers, those are the talented musicians, the violins, the cellos, the percussion. Now, each one is great on its own, but to create a real symphony, you need a conductor. You need someone to make sure they all start at the right time, play in the right key, and communicate perfectly with each other. That is exactly what Compose does for your containers. And this slide? Well, this says it all, doesn't it? We're replacing that long, messy shopping list of manual commands on the left with a single, elegant configuration file on the right. We just described the final state we want, our finished symphony, and Compose handles the really complex job of telling each musician exactly when and how to play. We just tell it what we want, and it figures out the how. Okay, so let's pump the brakes a little bit and actually look at that configuration file. This is the orchestral score for our application. And honestly, understanding how to read and write it is the key to unlocking the power of Compose. It's written in a format called YAML, which stands for YAML Ain't Markup Language. It's a little inside joke for us tech folks. It's designed to be extremely easy for humans to read and write. But don't let that simplicity fool you. There is one golden rule, one non-negotiable law that you absolutely, positively must follow. So here's the crucial point. Indentation is not optional. It actually defines the structure of the entire file. It works just like it does when you're writing code in Python. The spacing, and listen, it has to be spaces, not tabs, tells Compose how all the different pieces of the configuration are related to each other. If you get the indentation wrong, Compose won't be able to read the score. Your entire orchestra will be silent because the conductor's instructions are just unreadable. All right, let's actually look at the anatomy of a docker-compose YAML file. See that top-level key? It's called services. Underneath that, we define each of our containers. In this example, we've got two of them. One we've named book, which is our custom app, and another one called DBMS for our database. So let's break down what all these keywords actually mean. So everything starts under that services key. That's the main section of the file. And underneath services, you're going to list out each component, every musician in your orchestra, like your app server and your database. Okay, pay attention, because this is a really critical concept that trips up a lot of beginners. The names you give your services, in this case, book and DBMS, they're more than just labels. See, Docker Compose automatically creates a private network for your application, and these names become the network host names for each service. This means your application code can connect to the database simply by using the hostname DBMS. No more hunting for IP addresses. It's amazing. Inside each service, we use a few essential keywords to tell it what to do. For our custom book service, we use build to tell Compose where to find its Docker file. For the database, we use image to just pull a pre-built MySQL image straight from Docker Hub. Ports works exactly like it did with Docker Run. It just maps a port on our machine to a port inside the container so we can access our app. And finally, and this one is so important, we use depends on. This tells our book service to wait until the DBMS container is fully up and running before it starts. That one little line prevents a whole class of startup errors.
So we have our Docker files for each individual musician, and we have our docker-compose.yml score that defines the entire symphony. How does the conductor actually kick off the performance?
You know, the workflow is just incredibly efficient and elegant. It's really just 3 steps. First, you create the blueprints, your Docker files for any custom services. Second, you define how they all fit together in that single compose file. And third, you just run one single command to bring it all to life. And that single command is docker compose up. That's it. That is the conductor's downbeat. When you run this in your terminal, Compose reads your YAML file, it builds your app's image from its Docker file, it creates that private network, and it starts every single service in the correct order. All that complexity we saw earlier, it's just handled automatically. With one command, the entire orchestra starts to play in perfect harmony.
And with that one command, we've actually reached the end of our Docker journey. We've gone from a single, really frustrating problem to a universal, elegant solution. So let's take a moment and just recap everything we've covered in this series.
We started with that classic "it works on my machine" problem, right? Which was all caused by inconsistent environments. We solved that for a single app by using a Docker file to build a portable image and then run it as a container. But that solution created a new kind of complexity when we started dealing with multiple services that needed to talk to each other. And today, we solved that final piece of the puzzle with Docker Compose, giving us a universal deployment solution for pretty much any application.
So, after all of that, what are the most crucial points to remember from this entire series? What's the core knowledge that you should really take away with you? This table sums it all up beautifully. If you're facing inconsistent environments, your solution is to define that environment in a Docker file and build a portable image. If you need to access the app running inside that isolated container, you use port mapping, our friendly little receptionist. And finally, when your app grows and you're dealing with multi-container chaos, your solution is Docker Compose for that simple, single-command orchestration. We've gone from a local, really frustrating problem to a universal, powerful solution, the ability to package any application of any complexity and run it reliably, anywhere. That power is now in your hands. You hold the blueprint and the conductor's baton. Thank you so much for joining us for this series. Now go build something amazing.